Hi everyone, I'm Dennis Gravert, and this is the first video of Chem 29, the second semester of organic chemistry. So welcome everybody. Let's get things started. The way we guide our videos is through the use of key concepts. These condensed or abbreviated lecture notes that I have published on Canvas. Let me find the first one. Here we go. There we go. So welcome everyone. So we're looking at key concepts, Unit 1, Part 1. If you go to the module section in our Canvas course, you'll find it in Week 1, the Week 1 module. Okay, so where are we at? Well, last semester we talked about several functional groups. We talked about alkanes, alkenes, and alkynes, right? Carbon-carbon single bonds, double bonds, triple bonds. We also talked about alcohols and alkyl halides. And the way organic chemistry is organized is we just move from one functional group to another. So we're starting off with another functional group, the aromatic functional group. Excuse me, also known as arenes. So here's some terms you should be familiar with or become familiar with. There we go, arenes. Aromatic compounds, some people just call them benzene. Now, properly speaking, benzene is this one molecule, C6H6. Lots of different ways of drawing it. I've got all these drawings right here. Each one represents benzene. And I know sometimes people say, hey, look at this. Let's look at the molecules of benzene. And that means let's look at this molecule and put other things on it. Put an alcohol group on the benzene ring or put a methyl group, and it's still the same functional group with some decorations on it. Okay, the other thing you should know is that this is one of nature's favorites. She likes putting benzene rings into lots of molecules. And I think the reason for that is that when you put 6 carbons in a ring, alternating double and single bonds, that group of 6 carbon atoms is very, what's the word, very, very stable. And it's just a very popular functional group in nature. Okay, so let's explore this a little bit more. You need to be familiar with the different ways of drawing things, and I know you are. You may just need to refresh your memory from last semester. You know, there's the original way of drawing every letter, every atom, that is, all the C's, all the H's, put in all the bonds, the complete structural formula, if you will. And then there are skeletal drawings, and that's the more popular way of doing or drawing organic molecules. Nice shortcut. And the idea is that every time you see an intersection of bonds, like here's a double bond on the right connecting a single bond on the left, why is a single bond connected to a double bond? Well, it has to be at an atom, and that atom's going to be carbon unless there's another atom listed. And then we have to remember carbon bonds 4 times, right? So for this junction of a single and a double, that's only 3 bonds total to this topmost atom, which we know is carbon. And if it only has 3 bonds shown, carbon has to make 4 bonds. Any missing bond is a bond to hydrogen. Cool. Now on to benzene, or aromatic compounds, or the arenes. I know, lots of names. You can draw this specific molecule of benzene with a double bond on the top right or on the top left. It turns out this is a shortcoming of Lewis dot structures, is that Lewis dot structures don't actually properly grab the essence of the benzene ring. So to kind of capture this special stability, which we have a video devoted to that coming up after this one, we have to draw 2 resonance structures if you're trying to get the full picture, which still comes short. Sometimes the double bond's on the top right, sometimes on the top left. And in fact, it's not like take the molecule, flip it. No, hold the molecule steady. And as you study it, the Lewis dot structure might say the double bond's on the top right, sometimes on the top left. The real picture is more like this bottom one down here. We got this dotted line, right? So we're trying to say, hey, Lewis dot structures, you're failing us here to capturing the true essence of the benzene ring. So here's a better attempt. Let's put some dotted lines saying, hey, there's 3 double bonds. Now, what's a double bond? It's 2 overlapping p orbitals to make a pi bond. And then there's 2 electrons, the pi electrons that occupy that bond, that pi bond. So benzene has 3 pi bonds, 3 double bonds, if you will. And then where are those 3 pi bonds? They're anywhere about the ring. Or more importantly, each pi bond has 2 electrons. So benzene with 3 pi bonds has 6 pi electrons. Okay, so here's what's actually capturing the true essence of the benzene ring. Those 6 pi electrons can be anywhere about the ring. So this drawing says, hey, it looks like those pi electrons are up here on the side, on the right-hand side, and that's where they stay. And that's wrong. Experimental evidence says no. These 2 electrons sometimes are not even paired together. One of them heads off on the left side, the other one goes on the bottom of the ring and moves around. They can flow anywhere. So this drawing, or this one, kind of captures that essence of these 6 pi electrons are in free motion, going anywhere. And that actually contributes to its profound stability. And that's why it's a brand new functional group, right? Because back last semester, we talked about the alkene functional group, which is simply a carbon-carbon double bond. That's one functional group. And now we're introducing the arene functional group. And it looks like, hey, isn't that an alkene? Well, if there's only one double bond in a ring, yeah, it's an alkene. What if you have 2? Still an alkene. There's 2 alkenes here. But once you put in that third, don't we have 3 alkenes here? Nope. The reactions you can do with an alkene don't work on benzene or the arenes. They're a different functional group. Yeah. Okay, enough said about that. More coming up later. What else do we need to know? Well, let's move into naming molecules of benzene. Okay, so I kind of emphasize that, hey, this is one of nature's favorites. It shows up all the time. So before Iupac, right, the International Union of Pure and Applied Chemists, before Iupac was created, before an international committee, a whole bunch of scientists around the world got together and said, hey, let's devise a proper way to name molecules. Before that committee organized and came together and said, this is how we're going to name things. Scientists have been discovering all these cool molecules, and a lot of them had the benzene ring in them. They just started willy-nilly giving them names. And these names stick to this day. So you might consider these names on the screen. There's 7 molecules here. I would classify them as common names. They were the ordinary common name for the molecule before Iupac convened. But then when Iupac came in and tried to standardize things, give them the proper names, people rebelled and said, no, I don't care what Iupac says. We're still using these old names. And so Iupac compromised, said, okay, these common names are now Iupac names. And sorry, organic chemistry students out there in the world, now we have 8 names. Well, so far, there's a couple more coming for the benzene ring. So if you see just this thing, not well drawn, but you know what that is, I hope. 6 carbons in a ring, alternating double single bonds. The name for that molecule, the common name and Iupac name is benzene. But you attach a single methyl group on the benzene, this is not methylbenzene, which is a completely logical name. You will lose points on the exam. You will get frowned upon by the scientific community if you call that methylbenzene. Totally logical. Why not? Because Iupac said, nope, this molecule is not methylbenzene, the Iupac name. Nope. Before Iupac convened, this was always known as toluene. Toluene? Toluene. What? Where? I don't know. I haven't looked up the history of that word. But that's what we're stuck with. So memorize it. Sorry. Okay, toluene is one of the harder names, I think, to try and memorize. Okay, when methyl's on a benzene ring, and if you have 2 methyls, there's no. We'll get to that later. Single methyl group on benzene, toluene. If you put an alcohol group on the benzene, the name is phenyl. whatever. Lots of different ways to pronounce it, but only one way to spell it. Okay, we'll learn a little bit, actually later in this video. Fen is a nickname, if you will, for the benzene ring. So we got fen down here too. Okay, so there's some logic here. If you see fen in a name, it's referring to a benzene ring. And the ol, well, that's the suffix name for the alcohol group. The Iupac suffix for alcohols is ol. So benzene with an alcohol group, phenyl. Probably phenol is probably the more common pronunciation. So memorize that, but that has some logic. That's helpful. If you stick an amine, you stick an amine onto benzene, you make aniline. They both start with A. Acetophenone is when you have a methyl group and a benzene ring connected to a ketone. Okay, a ketone ends with -one, so we got the -one here. The fen is a nickname for benzene. Cool. What about this one methyl group? Well, 2 carbons with the double bond O is pretty common in nature. If you have an OH group, hey, that's a carboxylic acid. The common name and the Iupac name is acetic acid. So there's that ACET. And acetophenone is you got those same 2 carbons with double bond O attached to a benzene ring. So again, there's some logic there. Sadly, there's now 2 names that start with an A, but the one that starts with A and ends with -one has a ketone in it. Aniline is the one with the amine. Benzaldehyde. Thank you. Benz from benzene, aldehyde because of the CHO group, the aldehyde group, right? So that's a very common way to abbreviate the aldehyde group is COH, an aldehyde. Benzaldehyde, very logical name, maybe one of the easier names to remember. Benzoic acid, maybe just as easy, or a close second. The oic acid stands for a carboxylic acid, right? So the carboxylic acid group, we'll learn later in this semester that if you assign an Iupac name to a molecule with a carboxylic acid, the suffix is oic acid. And the benz, short for benzene. Yeah, so put carboxylic acid on benzene, you get 7 carbons in the molecule, and it's called benzoic acid. Styrene, why? Well, it does end with an -ene, which reminds me of an alkene. The alkene is attached to a benzene. Sty, I just think of a pigsty. That's not helping. Anyways, 7 names, 8 with benzene. We have to commit the memory. Yeah, so on an exam, you might get one of these structures drawn and the question will be, please name it, but there might be something else attached to it. So what Iupac did, it said, fine, hey, chemists, if you're not gonna call everything with the parent name benzene and you want us to stick with these 7 common names and we want to adopt them as Iupac names, well, now we're going to use them as often as we can. They are now parent names. Okay, so these common names are now parent names. What does that mean? Well, let's take a brief jump over here. Last semester, we talked about the Iupac system of naming. Right? Scientists love to assign every new idea a brand new term. So the term for naming compounds is called nomenclature. So there's a handout on Canvas. And if you have trouble finding it, I can help you out. But I believe it's in the assignment folder. When you go and look at the homework, it'll be one of the references and notes attached to that web page on Canvas. Anyways, you've seen this if you took my course last semester in Organic Chemistry 1, Chem 28. We discussed how to use the Iupac system for naming compounds. Essentially, every name, where's my pen? Like the name for this compound down here, you're going to have a parent that's going to identify the longest chain of carbons with the most important functional group given by the suffix. Any decorations are going to be prefixes out in front. There we go. Okay, so the parent name is part of the standardized name, the Iupac name. So when you're naming compounds, it's one of the things you want to do in the first 2 steps of assigning an Iupac name is figure out what the heck is its parent name. Well, if you look at a brand new molecule, like we'll name these 4 down here, if you see a benzene ring, you're using one of these 8. And a couple more in a few minutes. Yikes. Anyways, we got these 8 compounds, 8 names we need to memorize. Their parent names now. Okay, and after you get that idea, and you get those 8 names in your head, maybe flashcards, find an app on your phone that'll flip through some app, through those names, Quizlet, something like that, whatever helps you memorize these names. How do you use them? Well, when you're naming when you're numbering, right? What am I talking about? Let's go back to the handout on naming. There are 6 steps for naming compounds. First one you'll remember, hopefully, right? Or here's a little refresher. If it's been a while since you've named an organic molecule, step 1, you want to identify the longest chain or ring. That becomes the parent. Step 2, recall, memorize, in other words, what the parent name is, and then apply a suffix to identify the most important functional group, the highest priority functional group. Step 3 is the number of all those carbons. Step 4 is all the decorations, everything else that's not part of the parent. You need to name those pieces as a prefix, and you also have to assign a number where that decoration, that actual functional group, is located on the parent. So assign every additional functional group, alkyl branch, complex substituent, a number, right? So if there's a 6-carbon chain hexane, and on carbon 2, there's a methyl group, then 2-methyl is the number and the name, the prefix name for that methyl group, right? You got it. And then finally, lump all those prefixes in alphabetical order in front of the parent, and you got the Iupac name. Okay, so we're going to apply the same system to naming molecules containing aromatic rings. And here's a few things you just have to keep in mind. Those 8 first, memorize those 8 parent names, 8 choices. And then after you assigned a parent name, when you get to numbering the carbons in the ring, number 1's already been declared. The parent name, if you don't choose benzene, if you choose one of these 7, the parent name means there's already another group on benzene. And that group is on carbon number 1. It's on C1. So styrene, if you choose that parent name, the alkene group is on carbon 1. Benzoic acid, here's carbon 1. Wherever the carboxylic acid is attached to the ring, that is carbon 1 if you use benzoic acid as a parent name. Phenyl. I'm gonna be hung up about that. We give everyone a complex about how to say that word. Sorry. The alcohol group is attached to carbon 1 of the benzene ring automatically. That's the assumption. And if you choose not to put the number 1 in your parent name when you write out the Iupac name, it's totally acceptable because it's an assumption, an Iupac rule, that if you use one of these special names for benzene, carbon 1 has already been assigned to wherever that special functional group is. Okay, what happens then if you have more than one functional group? I have an example of that. Or in other words, what if there's 2 or more possible names to go with? I'll clarify that in a minute. The answer is you choose the highest priority functional group. So Iupac and their committee, where'd the naming rules go? Here they are. Go back to that handout. And on the second page of the handout is this ranking of functional groups, how they're classified and ranked. And the Iupac committee said, carboxylic acids, you're number 1. You're the most important functional group. Acid anhydrides are next in line, then esters, thioesters, acid halides, and so on. And you're thinking, well, how did they come about this priority system for functional groups? And they crudely follow the ranking that if it has more oxygen atoms and or more pi bonds, the double bond or the triple bond, it gets higher classified. There are exceptions, so be careful of that. One notable example is right here. So carbon-carbon single, a carbon-carbon double, carbon-carbon triple. The triple bond has 2 pi bonds. Shouldn't it be higher ranked? And the committee vetoed that. They didn't like that. They said, no, alkenes are more common. Let's make them higher priority than triple bonds. But if you look like at the alcohol groups, and then you talk about an aldehyde, and you say, well, which one's higher ranked? Well, they both have 1 oxygen, but the aldehyde has a pi bond and the alcohol doesn't. Okay, so that is following the trend. And the carboxylic acid's way at the top. Well, it has 2 oxygens and it also has a pi bond. So more oxygen atoms, more pi bonds, higher ranking. So do the same thing when you're trying to choose your parent name for benzene. So if you're looking at all these parent names, and what do you do if a molecule has both a methyl group and an alcohol group? Because it looks like you could choose either toluene because of the methyl group on benzene, or you could choose phenol because of the alcohol group on benzene. Turns out Iupac says, nope, you're choosing phenol because the alcohol group has an oxygen. That's more important than a carbon. More oxygens, more pi bonds, more important. So that's what this is trying to say right here, this bullet point number 2. Choose a parent name with a higher priority, higher priority functional group, more oxygen atoms, or more pi bonds, or both. And then just follow the same naming rules. So let's give it a try. Cool. Okay, got 4 of them here to try and hit on all these points, try and clear up all the tiebreakers and all that stuff. Let's see how we do. Oh, there's a little note here about the Nitro Group. In case I forget, let's mention it now. On the 3rd example here, we have NO2. That happens to be a very common functional group in organic chemistry. It's right here at the bottom of the list, so it's lowest ranked. The Nitro Group is a very common group. We need to memorize it. So if you see NO2, that you'll have to just memorize is nitro. If you have to draw a Lewis dot structure, the nitrogen atom is making 4 bonds, a double bond to 1 oxygen, a single bond to the second oxygen, and then it has its last bond to, well, it's usually a benzene ring. If it's attached to an alkane or some other functional group that's not super stable like benzene, it's probably part of an explosive. And anyways, enough said about that. They're very unstable. Okay. Yeah, memorize the name and structure of the nitro group. It's super common. All right, let's try naming some of these. So hey, on the exam, it's going to be one eventually, right? Kind of a necessary evil in education. The question might read, hey, assign no, it would just say name the following molecules. And on my exams, you can choose either a common name or an Iupac name if there's a choice. Okay, so name this molecule. Well, it's a benzene ring and 3 chlorines. So the first thing I do is I say, okay, step 1, I'm going to go after a parent name. I'm sorry, an Iupac name. So it's, again, someone once said organic chemistry is a memorization marathon. It's not a sprint. Don't try and cram, but there's lots to memorize. So when it comes to naming, my little brain says, okay, how do you name? 6 steps. I remember 6. Step 1, find the longest chain of rings. Step 2, assign the parent name. Step 3, number it. Step 4 and 5, all the decorations, assign a prefix and a number. Step 6, put them in alphabetical order. Okay, so if I am a student on the exam, confronted with this molecule with 3 chlorines and a benzene ring, and I'm asked to name it, I remember 6. Step 1, find the longest chain of ring. It's a ring of 6. Ooh, alternating double single bonds. That's benzene. Well, that's one name for the arene functional group, but there's 7 others. So then in your mind, you have to say, okay, chlorine on a benzene ring, chlorine on benzene ring. Okay, this chlorine on a benzene ring. Is that a special name? Now, I just showed you the list. I don't expect you to have it memorized, so we'll take a peek. Is chlorine on a benzene ring given a special name? No, chlorine's not anywhere on this chart that I totally marked up. So no, no special name. The parent name is benzene. Cool. That's step 1. Ooh, and step 2. Step 2, after you found the longest chain or ring with the most important functional group. That's step 1. Step 2 is to name it. Hey, this is benzene. Step 3 is number the chain. Okay, that's one of the tougher steps to do, you remember, because there should only be one way to number the parent. Iupac has all these tiebreakers, right? You're trying to first assign carbon number 1 to the first substituent or branch. So we can either put carbon 1 on this chlorine, or that one. You can't have all 3 possibilities. There's only one proper way to do it. So tiebreaker is needed. The second tiebreaker says, okay, if you have more than one group assigned number 1, break the tie by going to the second group as fast as you can. Okay, so if I call this first chlorine number 1, the second chlorine will be on carbon 3. So my numbers are 1 and 3. However, if I call this chlorine number 1, I can get to another chlorine on number 2. So that's better. It has a lower number. It's like playing golf. You want to keep your golf score down. Okay, so this top chlorine is not number 1. It might be this chlorine on the bottom right. It also could be the bottommost one, right? Because if I call this chlorine on the bottom number 1, number 2, the second chlorine is right over here on the right. Okay, so it's a tie. So to break the tie, go after the third group. So if I call this one 1, this will be 2, this will be 4. Or I can call this one 1, this one 2, and then 3, 4, 5. No, you take the lower one. So now we've broken the tie at the third functional group. We now have the one and only correct way of numbering this molecule. We start right here at the bottom. That's chlorine, that's carbon number 1. And then we go counterclockwise. 1, 2, 4. Nice. That was step 3, numbering the parent. Done. Yeah, what's step 4? Go around the parent and find all the extra decorations. Those are the chlorine atoms. Give them a name, chloro, and then assign them a number. Well, there's a 1 chloro, a 2 chloro, and a 4 chloro. Ooh, but if you repeat the same prefix, you don't put chloro, that word, 3 times the name, right? You say trichloro. And that's the prefix name. You got to keep all the numbers, though. It's 1, 2, and 4. And then the punctuation, you separate the numbers with commas, separate a number with a letter with the dash. Got my numbers, got my prefix. Then you end with the parent name and the suffix. Well, this one doesn't have a suffix. It's benzene. Done. Nice. Okay. On the second one here. Step 1, find the longest chain or ring with the most important functional group. We got a benzene ring. We got an alcohol. We have a halide. Where are my carbons? There, hey, here's a ring of 6. Ooh, that's benzene. But benzene has 8 possible names. So can I use one of the other names here? And the answer is yes. When an alcohol is attached to benzene, the name is phenol. Yep, so this molecule has the parent name phenol, and step 3 is the number the chain. Well, automatically carbon number 1 is right here where the alcohol is attached. That is number 1. Now the question is, do I go counterclockwise or clockwise? Well, whichever gets you faster to the next branch or substituent. So I go counterclockwise so that I hit the bromine on carbon 3 and then name a number. It's 3-bromo, phenol, we're done. Cool. Okay, that wasn't too bad. The trick though is you have to have phenol memorized and recognize it here, right? Yeah. Okay, we got this one here. Well, we talked about NO2. That's the nitro group, but its lowest rank. It's not showing up on any of these special names. Anybody else showing up? Yeah, what the heck's this functional group? 2 oxygens. Looks like a ketone and alcohol together, which it's not. It's neither a ketone nor an alcohol. It's a carboxylic acid, ic acid, ic acid, ic acid. Sounds familiar. Yes, benzoic acid. That's the parent name. So I like circling the parent. I'm a visual learner, so this is helpful to me. Those atoms I just circled make up the parent, benzoic acid. And then where's carbon 1? Right where the carboxylic acid's attached. Step 3 says number the ring. Let's go clockwise so we can get to the nitro group immediately on number 2. And then how do you identify that there's a nitro group on benzoic acid? Well, you use the prefix nitro and you identify the nitro is on carbon number 2. 2-nitrobenzoic acid. And we're done. Nice. Okay, so the last illustration here is trying to try to illustrate, well, what happens if there's 2 possible parent names, right? So hopefully it's showing up on your screen. I should have searched the internet a little harder to find something. There's double bonds in this ring if you can't see them, if you have a low resolution on your phone. Anyways, that's a benzene ring, alternating double and single bonds. There's a methyl group over here on the bottom left, an alcohol group on the very bottom. So we technically have 3, yeah, I guess 3 parent names to choose from. Is it benzene because of the benzene ring? Is it toluene because of the methyl group? Or is it phenol because of the alcohol? Okay, well, it's not benzene, right? So benzene is the lowest priority among all these possible parent names. If you can choose one of the other 7, that's what Iupac wants to do. Don't use benzene if you can use one of these 7. Okay, so it's not benzene. Some of you already remembered, wait, you go with the higher ranked priority group, which means more alcohols, more oxygens or more pi bonds. So the alcohol versus methyl, there's an O in the alcohol function group, it wins. So the parent name is phenol. Phenolphthalein, phenol. And where's carbon 1? Right where the alcohol attaches. So the methyl group is on carbon 2. If you use the parent name toluene, I'll give you partial credit. You can't give full credit. That's not the proper name for this molecule with the methyl group on phenol. Okay, cool. So that's pretty much how they name molecules that contain an aromatic ring. Excuse me. What's next? Slide up. There's more in our key concepts somewhere. There we go. Oh, yeah. Another compromise by Iupac. So common names. It's very common to have, these 7 molecules in nature. It's also common to have 2 functional groups on benzene. So before Iupac even was created, scientists, were already naming molecules that contain 2 functional groups on a benzene ring. And because benzene is a ring of 6, a hexagon, if you have 2 groups on benzene, there are 3 isomers, 3 ways of putting those 2 groups. So before Iupac convened, they already had a way to identify the positioning of these 2 groups on a benzene ring. They said, hey, if 2 groups are side by side, that's the ortho isomer. If 2 groups are opposite each other, that's the para isomer. And the third possibility is where they skip a carbon. So you have 1 group, skip a carbon, then you got the next group. That's the meta isomer. And what they did is, well, I don't want to introduce this, but you'll see in the homework, xylene, that is a common name. It's also Iupac accepted, but it's not that useful. It's not that common as a common name. Go figure. So it's not required on exams. I do not require that you memorize xylene. There's just little opportunity to use it. But hey, chemistry majors, biochemistry majors, you need to be aware of xylene. You'll encounter it on occasion as you continue your chemical career. So hey, I feel like good. I've introduced the word xylene to those of you who may need it, and the rest of you relax. You don't have to memorize xylene, but it's out there. Okay, so xylene is benzene with two methyl groups. O-xylene or orthoxylene, there it is, orthoxylene or O-xylene is when those two methyl groups are side by side. Metaxylene or M-xylene is when the methyl groups skip a carbon. And then paraxylene, P-xylene is when the methyl groups are opposite each other on the benzene ring. And this ortho, meta, para label, the O, M, and P, the ortho, meta, para that shows up in the name, you can apply that anytime you have benzene with two groups. Ooh, but only two. Not supposed to use it if there's 3, 4, 5, or 6 groups on it. Oh, and it has to be benzene. Don't use it on cyclohexane, a ring of 6. That's not benzene, cyclohexane. So anyways, Iupac fought hard to say, isn't it easier to call orthoxylene 1,2-xylene? That's logical. Metaxylene, why don't we just call it 1,3-xylene? Para is 1,4-xylene. People wouldn't budge and said, no, I don't want to go relabel all the bottles in my lab. Lazy people. So we're stuck with both possibilities. Iupac accepted ortho, meta, and para as Iupac labels, but you and I can go ahead and keep using numbers. That's my preference. So you're not going to see me say paraxylene very often. I'll be saying 1,4-xylene. Now, on the other hand, as an instructor, I need to make you aware of this because it is really common. So on the exam, you may be asked to name something with two groups on it. You can choose to use ortho, meta, or para. You can also choose to use the numbers. You get credit. You don't have to do both. You get credit when you're naming it, whether you use the ortho, meta, para, or the one or the numbers. Okay. However, there's another type of question on the exam where I say, hey, please draw for me. And now I get to pick. And to be fair, to give you a proper education, that's what I mean by fair, sometimes I'm going to ask you to name, 1,3-methylphenol. Or I might say, please draw, did I say that right? Please draw, let's draw 1,3-methylphenol. Or I might ask, please draw meta-methylphenol. Okay, so if I ask you to draw something, that's when you need to have the ortho, meta, para memorized. You have to know. Ortho side by side, paras across, meta, you skip a carbon. Okay, so let's give it a try. Here's some examples. And I like memes. Send me your chemistry memes. I'll try to include them in our Canvas page and homeworks and stuff. Xylene, why you know dimethylbenzene? I know, totally logical, but no one names it that way. Not Iupac accepted. So sad. Okay, so here's a possible exam question. Hey, can you assign 2 different names to these molecules? Yes, we can, because there's 2 groups on a benzene ring. So we have 2 ways of identifying their positions, ortho, meta, para, or with numbers. So this question say, hey, give me both names. All right, so first you say, hey, there's a benzene ring. Is there a special name with chlorine on the ring? Nope. How about a special name when bromine's on the ring? Nope. Parent name's a benzene then. So you can say, hey, the 2 halides skip a carbon. This is the meta isomer. Or you can say the 2 chlorines, well, 2 chlorines, 2 halides. 2 halides are on, well, one's on carbon 1, one's on 3. Who's on which one? Ooh, this is a little more difficult. Maybe you might want to go ahead and use orthometapara and skip the extra work. Iupac does have a method though. They say, okay, if chlorine's number 1, then bromine's on 3. But if bromine's number 1, then chlorine's on number 3. That's a tie. So break your tie with the third branch. Oh, there are no third group. Okay, now the final tiebreaker is alphabetical order. So B before C. So the Iupac name is going to be 1-bromo, 3-chloro, benzene. But gotta admit, it's faster to recognize those are meta to each other. The halides are skipping a carbon. So this is simply meta and then alphabetical order. Alphabetical order, meta, chloro, brain. This says bromo, chloro, benzene. There we go, meta, bromo, chloro, benzene. If you give me either name on the exam where I ask you to name it, get full credit. If I happen to ask for 2 names, you gotta give me both. Done and done. Next one. Okay, gotta name it. 2 names. Well, yeah, there's 2 groups. There's this group and there's that group on benzene. So I can use orthometapara. Which one is this? Ortho, right? So you can just put a little O there. They're also on carbons 1 and 2. That's going to be the other way of naming it. Step 1, however, was find the longest chain of ring with the most important functional group. The longest ring here is a ring of 6, benzene. Ooh, but do we have one of the special names? So look at the functional group. We have an aldehyde here, and we have an ethyl group, right? So be a little careful with that. It looks like it's toluene in a sense. No, there's a second carbon here. Sorry. I'll try not to do that on purpose, but right, if you're searching the internet, looking in textbooks, different authors, right, structures differently. We got to get ready for all possibilities. This is an ethyl group. Was ethyl on a benzene ring a special name? No, it's not. How about an aldehyde group on a benzene? Aldehyde with benzene. We'll say it the other way. Benzene with aldehyde, benzaldehyde. Yeah, this group right here is benzaldehyde. Cool, and where's carbon 1? Right where the aldehyde group's attached to the ring, which means the ethyl group is on 2. Okay, so you can say this is 2-ethyl benzaldehyde. It's okay to leave out the 1 because everyone should know if they've taken a little chemistry and they see the word benzaldehyde, the parent name that's identifying the aldehyde group is on carbon 1. So you don't have to put it in there. If you put it in there, I'll give you full credit. It's not incorrect. It's a little redundant, but I won't take off points because it's still correct. If you put a 1 in between ethyl and benzaldehyde. But you could just simply said, hey, an ethyl group is side by side the ortho position right next to benzaldehyde. So ortho or O, ethyl benzaldehyde, is also an acceptable Iupac name. All right, a couple more just to give us a little more practice. Let's name these compounds. Yeah, and this is more similar to what could be on the exam. I got 3 groups on benzene. Can I use, hey, these top 2 look ortho to each other. The halides are para. Don't use orthometapara in your name. You'll lose points. You can only use orthometapara when there's exactly 2 groups on benzene. This has 3. Doesn't matter you have matching chloros. Iupac says, nope, there's 3 groups on here. Cannot use orthometapara. You must use numbers. Okay, first, what's the parent name? Well, maybe benzene. How about with chlorines on a benzene? No. Methyl on benzene. Yeah, the weird one. A methyl's on a benzene. That's toluene. And where's carbon 1? Right there at the methyl group. Okay. Step 3 is numbering. Do I go clockwise or counterclockwise? Where's number 2? As fast as you can get to another functional group. So it's on the right, so go clockwise. The other chlorine must be on carbon 5. All right, so then throw your prefixes with their numbers out in front of the parent name. And we have 2,5-dichloro toluene. Doesn't quite roll off the tongue, but that's what we get. Oh, these methyl groups are opposite. Can I use para here? Well, is it benzene? No, it is not benzene. So every hexagon is not benzene. Even though it's nature's favorite, this is not benzene. Not benzene. You cannot use O, M, or P. Sorry, you lose points. Big time. Because it's telling me you don't recognize the benzene ring. Sorry. Ugh, I hate grading. Yeah, so earn all your points. What's the parent? Cyclohexane. That's not a benzene ring. That's cyclohexane. And where's carbon 1? Well, it could either be at the top or at the bottom. So break the tie of the second functional group. Well, if the top one is number 1, the bottom methyl group's on 4. But if the bottom one is number 1, the top one's on 4. So break it with the third functional group. There's no third functional group, third branch. Okay, put them in alphabetical order. They're both methyl. So here's a clean tie. You're going to get the same name, 1,4-dimethyl cyclohexane, whether the top one or the bottom one's number 1. So it doesn't matter. 1,4-dimethyl cyclohexane. And I know cyclohexane, wait, that was last semester. We still have to remember how to do that. Chemistry. Chemistry is a cumulative topic. Yeah. You have to remember all that. Okay, how are we doing for time? We're going quite a ways here. Oh, wait, that's the end of it. Nice. Okay. I guess 3 more main ideas. Iupac. And compromises. Okay, so the committee convened. They named things benzene. People argued and said, okay, we got 7 more parent names for a total of 8. Then when they got to this topic, molecules containing only carbon that also have the benzene functional group. Okay, so what are we talking about? We're talking about arenes, molecules of the benzene ring, and put alkyl branches on it. Alkyl substituted arenes. So Iupac has its own section about how to name these molecules. And sorry, it's also in our standard topics for organic chemistry. Okay, so if you have carbons, just carbons connected to a benzene ring, here's the game plan. You choose the parent to be whoever has the most number of carbons, the greater number of carbons. Yikes, the chain of ring with the higher priority functional group is the parent. Okay, I put that in here in case you encounter this, right? So this has a chain of 2 carbons and a ring of 6. So technically you could say this is an alkyl substituted arene, but it also has an aldehyde group. That's the highest priority functional group. It has an O and it has a pi bond. Okay, so in my notes here, if you have to name molecules that have an arene and an alkyl group, the parent name is going to be identified with the higher priority functional group. Okay, so basically I'm saying everything we discussed so far, keep doing that. Okay, however, if you run to a case where you just have alkanes in benzene, you don't have a higher priority functional group to break the tie to define the parent, here's what you do. Tiebreaker number 1, the chain or ring with more carbons becomes the parent. I know, it's a special case. So this is where you purely have molecules with only alkanes, only carbons, alkyl groups stuck on a benzene ring. If you just have that, you have to go with the chain or ring that has more carbons and make that the parent. I don't like it, but once you get used to it, special case, it's kind of set in your mind, then it's not too bad. That's not too bad. It's pretty straightforward. Just decide who has more carbons, a chain or ring. If, here's the big if, You only have alkanes on a benzene. And there'll be times when that tiebreaker, I'm sorry, when that will still be a tie. The longest chain has 6 carbons, and it's a benzene with 6 carbons. It's tied. What do you do? Iupac says, if you have a chain of 6 on a benzene ring, choose either hexane for the chain or benzene for the ring to make the less complicated name. All right, let's have some examples in a minute. At the same time, I want to introduce the prefixes here. So what are we going to do with this first tiebreaker? Let's say we have some benzene, we have a benzene ring, and we stick some carbons on it, and we stick 7 carbons of a chain onto benzene. And now this step right here, the tiebreaker says, hey, who has more carbons, a chain or a ring? If you have a chain of 7, that's more than 6 of benzene. So the chain of 7, heptane is your parent. Well, now, how do you identify the benzene ring? You can't use the word benzene or any of the other 7 names because those are parent names. You have to use a prefix name. Remember when we had a chain of 7 back in last semester? 1, 2, 3, 4, 5, 6, 7. Good. The Iupac name was heptane. But if you stuck these 7 onto something, you used the prefix name heptyl, right? You had to drop the ane and add the YL to identify, hey, I got a chain of 7 still, but it's not the parent. It's a prefix, it's a decoration. But a chain of 7, that is the parent, ends in ane. Same premise, same concept here. If benzene, a ring of 6, alternating double single bonds, is not the parent, you can't use benzene. And then people would say, well, can I just change the YL and call it benzoyl? I would think so, but no. Sadly, before Iupac convened, benzoyl had already been identified as the group containing benzene and 1 more carbon for a total of 7 carbons. And then you stick another group on that 7th carbon outside the ring. These 7 carbons is a benzoyl group. Phenyl is the name for benzene when it's not the parent. So if this molecule, if you identified, hey, whatever the R, the remainder of the molecule is, if you said, well, oh wait, this ring of 6 is the winner, it's the parent, then you'd use the name benzene. That's the parent name. But if you looked at this molecule and say, oh wait, the R group is the winner, we're going to use the parent name here. Then what are we going to do with this ring of 6? You can't use benzene. You have to use phenyl. Phenol, like phenol. Okay, so that's a tricky point. So just kind of get that in your head. Benzene looks like benzoyl, but there's actually carbon. Phenyl is the prefix name for benzene. Yeah. Okay, I think we're armed and ready. Let's give it a try. Well, here's some examples. Just kind of clarify it before we move on to some examples. Benzochloride. Yeah, we got these 7 carbons with an attached chlorine. Okay, so I need you to know what benzyl means, be able to use it in a name, be able to take the name and draw it. So if I ask you to draw benzoyl fluoride would be a ring of 6, and you decide how you want to draw it, benzene. And then put another carbon on there. And then to that extra carbon, add the fluoro group. And that'll be benzoyl fluoride. Benzyl cyclohexane, well, what's the parent? Cyclohexane, a ring of 6, all single bonds. What's attached to it? 1 more carbon than benzene, the benzoyl group. Yeah, okay, what about this one? It's a ring of 6. A ring of 6, who wins? That's a tie. So you can call the parent cyclohexane if you wish. And if that's a parent, can't call this one benzene. You have to use a prefix name phenyl. Phenyl cyclohexane. Or you can say, wait, I'm going to say this ring of 6 wins. So I get to use the parent name benzene. Then you can't use cyclohexane for this. You have to change it to YL. Cyclohexyl benzene. Okay, that's how the game's played. Let's give it a try. So, oh, I already have the answers here. Dennis, you're cheating. I'm sorry. Okay, let's play the game anyways. Pretend the answer is not right there. Okay. The question would be name these molecules. Okay, step one, find the longest chain or ring with the most important functional group. So what do I have? I have a ring of 6. I have a chain of 2. But where's the most important functional group? The alcohol group. Most important functional group is on the chain. So that just, Iupac said, yeah, make sure the parent has the most important functional group, regardless of length, regardless of number of carbons. So ethane, the 2-carbon group beat out the 6-carbon ring because it had this most important functional group, the alcohol group, the ol group. So on the chain 6, chain of 2, the ethyl group, that's not your parent, it's ethane. And then what's the suffix? Ol, the most important functional group. Step 3, number the chain or ring. Number the parent so that the highest priority group gets the lowest number. So the end of this ring, end of this chain of 2, the ethyl group, that's where carbon 1 is. And then here's number 2. And that's where the benzene ring is attached. And what's the prefix name for benzene? Not benzoyl, it's phenyl. So on carbon 2 of ethane, there's a phenyl ring, the benzene ring. And the highest priority group is the alcohol group. And if you want to put in the number 1, you may. You don't have to, because if you take organic chemistry and you say ethanol, you know the ethane means 2 carbons, ol means an alcohol. If there's only 2 carbons, the alcohol must be on carbon 1. But if you give me the names with the numbers, or with the number 1, I don't take off points because it's not incorrect. Yeah, the alcohol group is on carbon 1. Just saying that most people will drop it. All right, let's do another one. Over here on the right, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. How come I don't say there's 10 carbons in the chain? Because ring carbons are not chain carbons. So identify your ring carbons first, and they cannot be, they are not chain carbons. Chain carbons. Hey, sorry, ran off my writing pad here. Okay, so there's a ring of 6. This carbon is part of the ring, not part of the chain. So I have 9 in my chain. Okay, Iupac, what do you say? Step 1, identify the parent chain. That's the longest chain or ring with the most important functional group. Alcohol wins. So the alcohol identifies the parent. It's on a ring of 6, a benzene ring. And the parent name is phenyl. And where's carbon 1? Right where the alcohol is attached. Okay, so how do you get to the branch? This decoration of 9 carbons. I know, wait, I thought 9 carbons beat 6. Silly Iupac rules, sorry. The most important functional group identifies the parent, regardless of chain length. Yep, the ring of 6 had the little, the magic ring here, I don't know. And the most important functional group, the alcohol, that made it the parent, the ring of 6. So we get the parent name phenyl. Okay, and then on carbon 4, going clockwise or counterclockwise, we can find the branch point, decoration of 9 carbons. 9 carbons all single bonded is nonane. Remember your alkane names? But nonane's a parent name, so you have to drop the ane and add YL. So there you go, 4 nonol, phenyl, or you could use para. There are 2 groups on the benzene ring, an alcohol and a 9 carbon chain. So you can say this is p-nonylphenyl. They both work. Don't give me both names, just give me one, whichever one you think of first. Cool. Okay, this one's silly, but it's there just to emphasize the point. Hey, we got a chain of 2, got a ring of 6, ring of 6 wins. Parent name is benzene with an ethyl branch. If you want to put a 1 in front of it, you can. You don't have to, it's redundant. Has to be. If there's only one group on benzene, of course that group is on number 1. Yes, but if you have a ring of 6 and a chain of 9, and that's it, no one has a higher functional group, Iupac says the longer chain wins. Dang it. Okay, so a chain of 9 wins. It's greater than 6. So this is nonane. I like circling the parent. Ring carbon is not a chain carbon. And then now I need to number this chain. So do I number on the left? No, you want to number it as close to the branch as you can. I know that's weird. If you look at the whole molecule, the numbering shows up in the middle of the molecule. Iupac, why? Because they said the longest chain of 9 beats a ring of 6. Nonane is a parent. Now number this parent chain of 9 carbons right here. That's the first carbon of 9. And that's because benzene's located right there. Oh, but I can't say this is benzene in the name because benzene's a parent name. It goes at the end. This is a prefix. This is an extra group attached to nonane. So I have to use phenol. That sounds like phenol. Dang. Phenol? Phenol? Sorry. I'm passing on my nuances, my hang-ups to you guys. Sorry. Just spell it correctly and you're good. OL means alcohol. YL means just a plain benzene attached to something. And we're good. Okay, we got the second tiebreaker. I want an example of that. It doesn't show up too often, but here we go. Okay, I got a molecule with only carbons in it. So who wins? Well, whoever has more carbons. We got a ring of 6. I got a chain of 9. I have a second chain of 2. Well, you're going to lose the greatest number. And then nobody has a higher functional group. It would be an ugly name if the 2 carbon group had an alcohol. Yeah, ethane would be the parent. Okay, but that's not the case here. We have a chain of 2, chain of 9, a ring of 6. Greatest number wins because we only have carbons. Okay, so the parent name should be nonane. Carbon number 1 should be here, close to the branch point. But now you have to give a prefix name for this whole group. And Iupac will allow for complex substituents to be created using parentheses, but now it's getting too complicated. So Iupac has a loophole that says, hey, if you followed the rules correctly, kudos to you. But if it generates this really crazy name, you can break our rule and say, go back to the other one. Instead of saying the chain of 9's your parent with nonane, we will allow you to choose number 6, the next one down. And now your parent name is benzene. And now where's carbon 1? Well, it's either over here at the ethyl branch or over here at the nonyl branch. So find your third functional group to break the tie. No third functional group. Okay, break it alphabetically. Ethyl before nonyl, so ethyl wins. So this is 1 ethyl, 4 nonyl benzene. Or, hey, there's 2 groups on benzene. You could also use para or p-ethyl nonyl benzene. Phew. So go ahead and rewind parts of this video as you're doing the homework on naming, find pertinent points to help you out. And if you have any questions, post them in our discussion board, our weekly discussion board. That's where we dialogue with our classmates and with me. I'll jump on the discussion board and help each other out. But work these out. And if you can solve these, great. Post some answers on the discussion board. Help out your fellow classmate. All righty. Welcome to our first semester organic chemistry.